A groundbreaking chapter in environmental observation has just been opened with the launch of Europe's latest climate and air quality monitoring satellite. This milestone is marked by the successful deployment of the MetOp second generation A1, MetOp-SG-A1 satellite, which promises to revolutionize how Europe gathers critical atmospheric data for decades ahead. On 13 August, at precisely 0237 CEST, MetOp-SG-A1 blasted off from the European spaceport in Kourou, French Guiana, aboard the cutting-edge Ariane 6 rocket. The satellite separated smoothly from the launch vehicle and activated its solar panels a little over 2 hours later, signaling the beginning of its mission. This mission is not just about observing our planet's atmosphere with exceptional precision. It's about providing vital, real-time data necessary for monitoring climate change and air pollution across Europe and beyond. At the core of this satellite lies the advanced Copernicus Sentinel-5 spectrometer, engineered by Airbus Defence and Space in Germany. This sophisticated instrument is designed to scan the global atmosphere every day for a comprehensive range of gases and particles, including nitrogen dioxide, sulfur dioxide, ozone, methane, formaldehyde, various volatile organic compounds, VOCs, and atmospheric aerosols. The data collected will directly feed into the Copernicus Atmosphere Monitoring Service, CAMS, and the Climate Change Service, C3S, crucial for modeling air quality and tracking greenhouse gas emissions in line with European Union and international climate goals. But here's where it gets controversial. While this level of detailed atmospheric data can empower policymakers and scientists, to what extent will governments fully leverage these insights for meaningful environmental action? Does the technology guarantee real-world change, or could it simply become another impressive data stream with limited impact? The frequent and spatially rich datasets from MetOp-SG-A1 will substantially enhance national and local monitoring efforts, improving the precision of emission inventories and urban air quality forecasts. For example, cities struggling with pollution can design and refine intervention strategies more effectively, potentially saving lives and reducing health risks associated with poor air quality. Looking to the bigger picture, MetOp-SG is not a standalone project, but rather a strategic program involving a total of 6 satellites split into 2 series. 3A satellites will specialize in atmospheric sounding, tracking trace gases, and capturing detailed imagery, while 3B satellites will complement these observations with scatterometers and microwave imaging capabilities focused on land and ocean surfaces. This thoughtful A-B satellite pairing is engineered to maintain and enhance Europe's polar orbiting weather observation capabilities well into the 2040s. It will work synergistically alongside the METEOSAT third generation NTG satellites, which orbit geostationarily, providing continuous fixed-region data. This dual-orbit strategy enables a powerful global coverage approach. Polar satellites achieve wide, nearly complete Earth coverage, while geostationary satellites provide rapid, localized updates. Together, they significantly improve weather and climate forecasting models and strengthen early warning systems. For extreme events like storms, heat waves, and climate-induced natural disasters, the cooperative nature of MetOp-SG underscores its global importance. The European Space Agency, ESA, spearheads design and development, while the European Organization for the Exploitation of Meteorological Satellites, EUMETSAT, oversees operations and data flow. The Copernicus program, led by the European Commission, anchors the Sentinel-5 instrument within the mission framework. Additionally, collaboration with the United States NOAA through the Joint Polar System fosters international meteorological cooperation, effectively creating a transatlantic partnership in atmospheric monitoring. Phil Evans, EUMETSAT's Director General, aptly described this launch as delivering sharper tools to save lives, protect property, and build resilience against the climate crisis. This is no exaggeration. With shared datasets strengthening both European and American observations, the mission creates a robust global foundation for environmental intelligence. For professionals involved in air quality and climate research, Sentinel-5's capabilities are poised to transform daily operations. Satellite-based pollutant maps will validate and extend measurements from ground stations, notably filling gaps in regions where terrestrial monitoring is sparse or non-existent. Climate scientists, too, will benefit from consistent, long-term datasets that track short-lived climate pollutants alongside enduring greenhouse gases, allowing for more precise studies on the causes and effects of climate change. This brings up an interesting question. Could this level of data transparency put pressure on policymakers to be more accountable in meeting emissions reduction promises? Or will political inertia continue to block meaningful progress despite enhanced monitoring? Ultimately, having near global coverage with daily data refreshes is a game changer for verification and compliance efforts worldwide. Another remarkable aspect of MetOp-SG-A1 is its responsible approach to space sustainability. In a pioneering move for ESA-developed meteorological satellites, this series includes active deorbiting technologies. As each satellite reaches the end of its mission life, thrusters will steer it into a controlled descent, ensuring it burns up safely in the atmosphere. This measure helps mitigate the already critical issue of space debris, promoting responsible stewardship of orbital environments, something rarely highlighted but essential for the future of satellite operations. In summary, MetOp-SG-A1 stands as one of the most ambitious environmental observation missions ever launched from space. It offers an integrated perspective linking weather phenomena, climate dynamics, and air pollution monitoring. For the next generation of environmental experts, from atmospheric scientists to city air quality managers, this satellite's data streams could enable precisely targeted, confidence-backed interventions long sought after but seldom realized. And this is the part most people miss. MetOp-SG-A1 is only the pioneering step in a 20-year mission. Each satellite that follows will build upon its predecessor's advancements, forming a continuous, enriched record of Earth's atmosphere. Future generations of analysts and decision-makers may well regard this data archive as one of Europe's most invaluable legacies in combating climate change and protecting public health. So, what do you think? Will this sophisticated surveillance of our atmosphere finally push governments and industries toward real action? Or is it just another layer of data in an increasingly complex world? Share your thoughts and let's discuss how technology and policy must work together to tackle the climate crisis.